Hello again. So, this is the first of 5 short lessons on quantitative chemistry. Quantitative chemistry. Quantity, it's the maths about chemistry. How much, what are the quantities that we're dealing with, okay? So, I'm working through the booklet I gave you. Some of you didn't make all the lessons, so I hope it's useful. You can choose, obviously, which ones you watch. So, there's just 5 key learning points, and each one of them has got one of these numbers at the top of it. That number comes from the AQA specification for triple chemistry, whether you're doing higher or foundation, all right? And you can Google it. You can find it online if you want to actually have a look at that specification and see what's in it. So for those of you who are really trying to get every single mark that you can, I do recommend having a quick look at this specification. You can't study the course from it, but it's worth having a look just to see if there's anything you've missed, all right? So this is the first little bit, 4.3.1.2. And that's written at the top page in the booklet, okay? And that refers to one little bit of the specification. So this is number 1. What's it all about? It's about relative formulaic mass, or RFM, all right? And to understand that, we need to unwind just a little bit and recall what we know, what we already know so well about relative atomic mass, all right? Just remind yourself, relative atomic mass, or RAM, is the mass of the atom, all right? And all the atom's mass is in its nucleus, where the neutrons and the protons are found, okay? And it's the large number on the periodic table. That is the mass number, and that's the number we're dealing with here, okay? Just looking backwards, we're not looking at the atomic number, the number of protons on their own, which also equals the number of electrons, because remember, atoms are neutral, so they have to balance. We're looking at the mass number, which is this mass of the nucleus, okay? So relative formulaic mass is simple, really. It's the mass of the formula that we're thinking about, which is the total, the sum, that's a nice mathematical sign there, the sum of all the relative atomic masses involved, okay? We can also call the relative formulaic mass MR. So it's the mass of the whole formula. So let's just look at something. Glucose, I'm choosing glucose sugar. 6 carbons, 12 hydrogens, 6 oxygens. How are we going to work it out? We're going to look at the periodic table. We're going to get the mass of each of those different elements, multiply it by the number of atoms of that element, and find out the total, the sum total. Okay, so this really is step in quantitative chemistry. And what do we use it for? Well, we can use it to check and see if an equation is balanced, all right? So here's an equation. 2HCl, hydrogen chloride, plus magnesium makes magnesium chloride, where, remember, that's one molecule, so you cannot mess with that little number. That little number always stays the same. Magnesium is always joined onto 2 chlorines, okay? Plus H2. Is that balanced? Okay, how can we check that? Top tip from me, I've told you this in class, if the examiner hasn't given you the relative atomic mass of all the elements you're thinking about, write them down the side of the page, all right, in the margin, because you might need them again. So you don't want to have to keep looking them up. It wastes time and there's a possibility of errors every time you look it up. So you write them down. Chlorine, 35.5. Another thing to look back on. Why is chlorine 35.5? Because the relative atomic mass is the average of all the different isotopes of that element found on planet Earth. All right. Some elements, remember, appear in different forms, different isotopes. The proton number is always the same, but sometimes they have a different number of neutrons. So you take the average, and that's the number, the big number in the periodic table. All right. So we're simply going to have a look and make sure that the mass of the reactants equals the mass of the products, because remember, matter can neither be made nor destroyed. So 2HCl means 2 of that molecule, all right? Chlorine, 35.5, add hydrogen 1, makes 36.5, double it, we get 73. 1 magnesium, there it is, all on its own. Spot the deliberate mistake, 24. Then we've got magnesium chloride, which is 1 magnesium, add just 2 chlorines, the 71, and 2 hydrogens. So if it helps you, put the brackets in, put the boxes in to show the actual molecules that can't be tampered with. What we found here is that the mass of 97 in the products makes a mass of 97. A mass of 97 in the reactants makes a mass of 97 in the products. Correct, equation balanced, excellent. I suggest if you want to, you have a quick look at page 8 in the booklet and just do those, the top of the page, just those 5. Will only take you 5 minutes, and double check that you've got this bit before we move on to lesson 2. See you later, I hope.